Hello, this is Hatter Planetarium Director Ian Clarke, and we would like to welcome you to our virtual planetarium presentation for Family Weekend this year. Planetarium shows for Family Weekend are something that we have been pleased to offer in the past, and we're happy to be able to offer a virtual one this year. First, let me bring you up to date on what's going on in the planetarium. And as you might imagine, we are not currently offering public shows. What we are doing is preparing content for the future. We've also done some work with the astronomy labs. And what you're going to see right here, we're working on a new technology of virtual shows. They don't offer the immersive environment of the planetarium dome, but they do give us a chance to add something to our arsenal of planetarium outreach. So what you're going to see are three different presentations. One of them is a almanac and sky tour that we call Gettysburg Under the Stars. There will also be a presentation on recent astronomy news from one of our student presenters working remotely. And then finally, we'll have a video explainer on the autumnal equinox that we put out around September 22nd, the time of the most recent fall equinox. This is the time where I would probably tell you to remain in your seats for the duration of the show and keep cell phones and other light-making devices away. But I don't have to do that because you are somewhere, perhaps in the comfort of your own home, and can do all of those things if you so choose. But whatever your situation is, we thank you for your interest in the planetarium, and we hope you enjoy our presentations today.
Hello from your planetarium staff, and welcome to the Hatter Planetarium. I'm James.
I'm Meg.
I'm Garrett.
And I'm Ian. And this is Gettysburg Under the Stars. Hello, this is Ian Clarke from the Hatter Planetarium with a sky tour and almanac for Gettysburg for late October and early November. So let's get down to earth and see what the sky looks like. Here we are in the late afternoon, locally watching the sun go down. We're going to let time flow until about 8 o'clock and take a look around. So observe there the stars setting in the southwest to west. Now we're stopped at 8 o'clock. We're going to turn around and look for a sight of a couple of bright planets that are up right now. So there, southwest, we have Jupiter and Saturn. They don't look like that to the unaided eye. They look like bright stars. Jupiter to the right is whitish, and Saturn a little bit fainter and yellower to its left. And you can see them tucked there in between the figures of the constellations Sagittarius and Capricornus. Notice they're pretty close together. In fact, they're going to be getting closer and closer together over the next few weeks, reaching their closest in December. This is known as a great conjunction between those two big outer gas giant planets. How often does this happen? Well, we can take a solar system view in order to have a look. So here we are looking down at the solar system. Time is rolling by. We're into the middle of 2021 now. You can see Jupiter, and right behind me over here, there it is, Saturn. Jupiter, you can tell, is moving faster. However, we're going to have to speed up time because it's clear it's going to be a long time before it catches up again. So indeed, moving faster, you can see Jupiter rolling along. It orbits the sun once every 12 years. Saturn, slower, about once every 30 years. Now we're getting closer to catch up. And there we go. The next great conjunction will be in November of 2040. And indeed, they occur about every 20 years. So appreciate this one because they don't come along that often. Great conjunctions of those two outermost planets that are visible to the unaided eye, Jupiter and Saturn. Back on Earth again, once again looking west, we're going to turn around, swing by Jupiter and Saturn. And over here, more in the east to southeast, we have another bright planet, that's Mars. Mars is just past its opposition when it's at its brightest. For Mars, that happens a little over every 2 years. This one is particularly bright, and Mars shining like a bright reddish star, and it will stay bright for the next couple months even. The next opposition will be in a little over 2 years. However, there won't be another one quite this bright until 2035. Looking at the universe beyond the solar system, we're going to turn right now to the north. And this little group of constellations that you can see together there, Ursa Minor, the Little Bear, it's also known as the Little Dipper. Ursa Major, the Big Bear. Part of that constellation is the star group that we know as the Big Dipper. They mark the northern sky. The end of the handle of the Little Dipper, right there, is Polaris, the North Star. There we go. There's the pointer. Polaris, the North Star. You'll notice that roughly that the Big Dipper can actually never set from our location here at 40 degrees north latitude. It'll always go around and around the North Star there. And pretty much opposite the North Star from the Big Dipper is the constellation of Cassiopeia, the Queen. Queen Cassiopeia bragged about her beauty, said that she was more beautiful than the Nereids, sea nymphs. Poseidon got a little bit upset about this and sent a sea monster to torment her country. So, as one does in ancient Greek mythology, she and the king chained her daughter Andromeda to a rock as a sacrifice to said sea monster. Andromeda was, however, rescued by Perseus, the hero, and those constellations are clustered there together in the same area of the sky. Actually one of the few times that you can see a group of constellations together in myth. There are some others as well that go with those. Cepheus was the king of the kingdom, is nearby, and also Cetus, the sea monster himself. Those are somewhat fainter constellations. So that's a little bit of a look at the evening sky. Let's see what's going on in the morning. We've got another bright planet, and that's the planet Venus, which is visible in the early morning sky before sunrise. Right here, we're looking actually in early November, November 12th at 5:30. This is true of about an hour before sunrise of any time in the next month or so. You'll be able to see the bright planet Venus there in the east-southeastern sky above the horizon. The reason that I picked November 12th is because the moon in its monthly cycle through the skies is going to be nearby the planet Venus as a waning crescent, very thin waning crescent on the nights of November 12th and 13th. So keep an eye out for that. And then finally, here is the almanac for the next couple weeks for Gettysburg.
Molecule phosphine had been discovered in the atmosphere of Venus. Phosphine has been proposed as a bioindicator chemical, and research continues to narrow down the possible causes for its presence on Venus, which has long been assumed to be uninhabitable. This video will discuss the historical background of our search for carbon-based life on Venus, the significance of this recent discovery, and what impact it may have on future astrobiological research. Part 1. Venus. Venus is the second planet from the Sun, and most often the closest planet to Earth, though sometimes orbital geometry means it is either Mars or Mercury. Because of this, and because the two planets are similar in their size and rocky compositions, Earth and Venus are often considered sister planets. Venus' proximity to Earth makes it one of the brightest objects consistently visible in our night skies, and its similarities to Earth made it an early candidate in humans' search for extraterrestrial life. In fact, Venus became the first planet that we reached by space probe. When Mariner 2 flew by in 1962, relaying back information about Venus' temperature and atmospheric composition. The ultimate result of this exploration, however, was that we deemed Venus to be categorically uninhabitable to life as we know it. After losing contact with lander probes that were crushed under its immense atmospheric pressure, and finding little to no evidence of H2O anywhere on the planet, Venus has long been assumed lifeless. Part 2. Phosphine. So what was this chemical found in the atmosphere of Venus that has people so excited? After all, phosphine is a rather unassuming chemical in its appearances here on Earth. It is rare, and it is more often a byproduct of organical chemical reactions than it is a necessary component of them. However, it is strongly tied to one organic process that is as ubiquitous as life itself: decomposition. Phosphine, as you can see here, is a trigonal pyramid, meaning its four-dimensional shape has four sides, all triangles. It is comprised of one phosphorus atom and three hydrogen atoms, and the presence of phosphorus makes it a highly reactive molecule. It is formed in decomposing organic matter when phosphorus is present, and decomposition processes begin to shift the chemical properties of the existing molecules. Needless to say, if Venus is lifeless, there is no organic decomposition taking place there. Therefore, scientists needed to consider and rule out all of the other plausible explanations for its presence in the atmosphere. Dr. Clara Sousa Silva, an astrobiologist at MIT and one of the leading researchers in the articles published detailing the Venus discovery in September, has dedicated much of her career to studying phosphine and using chemical spectroscopy to identify it elsewhere in the solar system. Spectroscopy, briefly, is a process by which we can detect the presence of certain elements due to the specific wavelengths of light that they absorb. Before last month, we had only detected it in the atmosphere of gas giant planets like Jupiter, where the immense heat and pressure can naturally simulate the laboratory conditions required to manufacture it here on Earth. Venus, though it does have an extreme atmosphere relative to our own, simply does not have these same requisite conditions. And we would expect any non-self-renewing quantity of phosphine in Venus' atmosphere to have been long dissipated due to solar radiation. Nothing is definitive, but there is compelling evidence that the phosphine detected in Venus' atmosphere is a biosignature, a sign of life on the planet currently. Otherwise, it is coming from an as-of-yet unknown chemical process. Either way, this discovery represents enormous progress in the fields of planetary spectroscopy and astrobiology. Part 3. Supernatural Implications. In my research on phosphine, I came across a connection between the molecule and human mythology that I found way too interesting not to share. As I said before, phosphorus is a highly reactive element. This property sometimes causes high concentrations of phosphine gas to oxidize in the surrounding air in a chemoluminescent reaction. Ignis fatuus is the Latin name for this phenomenon, and it is known around the world under a number of names, including Aleia, Kirbati, Hitodama, Min light, Brujas, ghost candles, and perhaps most commonly, will-o'-the-wisps. Throughout human history and around the globe, appearances of ghastly light near graveyards and decomposing forest ecosystems have long been associated with spirits. The connection between death or spirits or ghosts is no mystery in the modern day, as we now understand that phosphine occurs most commonly as a byproduct of decomposition. Ecologies like graveyards and the forest floor have consistently high levels of decomposition, and it is no surprise, therefore, that there are relatively high concentrations of phosphine in the surrounding atmosphere. When the concentrations of this reactive gas become high enough, they react with the surrounding air, oxidizing in an ephemeral ghastly flash of light, known by its names like will-o'-the-wisp or any of its several names around the globe. What does this connection suggest about potential life on Venus? It is hard to say for certain, but it may suggest an ecosystem that us Terrans here on Earth could recognize, one with hierarchical food chains and different forms of life playing different roles within an ecosystem. But again, this research is very new, and nothing is known for certain. If there is a form of life existing somewhere on Venus, it is likely microscopic and specially adapted to what are very harsh conditions towards life as we know it, what we would call an extremophile. But its existence would suggest that carbon-based life may be far more common in the universe than we would have previously imagined. If life can persist under the extreme conditions of Venus, this would expand the range of what astronomers consider habitable planets in the search for extraterrestrial life. But even if life on Earth is not unique, that doesn't make it any less special. Our planet precariously sustains the conditions for complex life in ecosystems spanning air, land, and sea, and it is unlikely we will ever be able to visit another planet so well suited to our needs. For my part, I know that the next time I'm outside, I'll remember our new potential Venusian neighbors and take a deep breath with a newfound appreciation for fresh air. This is James, signing off remotely on behalf of the Hatter Planetarium. Thank you for watching.
Hello, and welcome to this special Gettysburg Under the Stars video about the autumnal equinox. the first day of fall. That moment of the equinox is about to occur as I make this video. What does it mean? What do the seasons mean? Well, first we can forget the hoaxes about balancing things like brooms and eggs. The root of the word is equal nights, and indeed the days and nights are roughly equal now. Due to some technicalities about the way sunlight bends through the atmosphere and the way we calculate the time of sunrise and sunset, if you look it up in an almanac, you'll see that it's not quite exact. But that is, again, the root of the word. That is not, however, the scientific definition of equinox. Let's see what is. There we have the sun at the time of equinox. According to the definition, the equinox itself is the moment at which the sun, from our perspective on Earth, crosses a line known as the celestial equator. It's parallel to the equator of the Earth. It's the red line right there. When the sun crosses that line going from the north to the south, that is the September, or for those of us in the northern hemisphere, autumnal equinox. That is the scientific definition. That may not give us a great insight, however, into the seasons. So let's have another look. This is a diagram which probably you're pretty familiar with. I should point out that the size of the Earth is massively magnified in this view, giving somebody the idea that the one hemisphere is actually appreciably closer to the sun and the other hemisphere is farther away. That's not right. It's the tilt which makes the difference. Have a look at this image of the Earth right here. This is what you would get if you looked at the Earth through a telescope from the sun and took a picture every day of the year and put them all together into an animation. This gives you a pretty good idea of what's happening. The sunlight is falling more directly on one hemisphere for part of the year and more directly on the other hemisphere for the other part of the year. The way we perceive the seasons from Earth has everything to do with the path of the sun in the sky. Now this is kind of a fisheye view. It's a little bit hard to get a hold of, but that is the path of the sun on June 21st from our latitude. It rises well to the north of east, and on the equinox, this is the September equinox, it could really be either one. The sun rises due east, crosses lower in the sky, and sets due west. The winter solstice, December 21st or thereabouts. The sun rises way in the south of east and sets in the south of west and takes a really shallow path through the sky. These three paths of the sun together create how we perceive the seasons. We get stronger sunlight and longer sunlight in June, and weaker sunlight and less of it in December.